2012 AMC, this is problem 12 from the AMC12A, and says a square region ABCD is externally tangent with the circle, so let's see, it is externally tangent to the circle with the equation x squared plus y squared equals 1. And at the point 0, 1 on the side CD, and vertices A and B are on the circle with the equation x squared plus y squared equals 4. What is the side length of this square? And when we look at this, I'm going to have to do a little bit of, I think, some geometry and actually graph these on the plane and see what happens, but let's see what this looks like. So, x and y axes. Well, that's a bad axis, but whatever. This is the circle centered at 0, 0 with radius 1. That's a really bad circle, but whatever again. This is the circle centered at 0, 0 with radius 2. So we got this, it's not a donut, it's a washer shape. And we have this square that is externally tangent at 0, 1 with this inside blue circle, and then points, so this is square ABCD, A, B, C, D, and we can see now that externally tangent at 0, 1 on the side CD, A and B are on the outside circle. And when we first look at this, it might be a little bit tricky to see, but here's the idea. There might be other ways to solve this. This is just the first way I saw. The square region has to be cut in half here, which means that, let's just say that this is some, I don't know, let's call it, what do I want to call it? Let's call this, I'll just call it alpha for lack of a better term, and then this is going to be 2 alpha because it's a rectangle, it's half of a square, and that means that we can see now that B must be on the line, so B must be on the line, y equals slope of 2, because it has to be, this sort of rectangle right here has to be twice as tall as it is wide, 2x, and it goes through 0, 1, so that's the y-intercept plus 1. But we also know that B must be on x squared plus y squared equals 4. And now I just have a nonlinear system to solve, and I'll get my answer. So let's substitute 2x plus 1 in for the y. So I get x squared plus 2x plus 1 squared equals 4. And now square some stuff through, so I get x squared plus 4x squared plus 4x plus 1 equals 4. It's a quadratic, so I have 5x squared plus 4x. I'm going to subtract 4 from both sides to get minus 3 equals 0. I look at it, it's not looking like it's factoring well, so let's just jump straight to the quadratic formula. So I know x equals, and then, so x equals -4 plus or minus the square root of 4 squared is 16 minus 4 times 5 is 20 times 3 is 60, but it's a -3, so I get a plus 60, all divided by 2 times 5, which is 10. And that means that this x is either, so it's -4 plus or minus, I have this square root of 76, and let's see, 4 goes into 76 how many times? 19 times, so this is 2 root 19, and I see a root 19, it's probably my answer, but let's keep going. So 2 root 19 all over 10. And, okay, so I can reduce this down. Everything has a factor of 2 in it. So this will then equal, let's say, -2 plus or minus 1 root 19 over 5. So we factored out 2's on the top and bottom, canceled them out. So that means that my x values are -2 plus root 19 over 5, or -2 minus root 19 over 5, but I'm looking for a positive x value, so we have the only one that I actually care about is -2 plus root 19 over 5, and this will measure this length here, this x value here, so it is this x value for b, and I know that the overall length, side length of the square, which is what I'm looking for, is twice that, so that means that the side length is 2 times -2 plus root 19 over 5, which is, of course, and they rewrite it with root 19 out front, so it's 2 times root 19, 2 root 19. 2 times -2 minus 4, all over, you don't multiply those, 5. Answer is D.